The first part of today's lesson is on properties of parallelograms, and so of course what we need to start with is the definition of a parallelogram. What is a parallelogram? Well, it's a quadrilateral with both pairs of opposite sides parallel. That is a parallelogram. And sometimes when I'm rushing, I might write it, you know, that's the symbol for parallel, and there's an O, and sometimes I'll abbreviate parallelogram like that, and you're free to do that too. With symbols, if you see this symbol beside something, that is also an indication that we have a parallelogram, and what we just learned by the definition is that both pairs of opposite sides are parallel. All right, and then we have a bunch of theorems coming up in the next few lessons, so you definitely want to stay up to date with your flashcards. They don't have names, so if you use them in a proof, you'll just have to paraphrase them as we've done in the past. Here's the first one. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So not only are the opposite sides parallel by definition, but by this theorem, we know that the opposite sides are congruent. Next one. If a quadrilateral is a parallelogram, then its opposite angles. Opposite angles are congruent. Okay. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. And of course we know why, because right, think of this. If PS is parallel to, well, no, never mind. I was going to say something that I don't think is going to hold up just yet. So we'll leave it at that. Consecutive angles are supplementary. Oh yeah, here's what I wanted to do. If that's parallel to that, and this is my transversal right here, then remember I learned a long time ago that if parallel lines are cut by a transversal, consecutive interior angles are supplementary. So that's what I got there, is consecutive interior angles. All right, and let's see what we have next. If a quadrilateral is a parallelogram, then its diagonals bisect each other. So I can see by the markings here that that diagonal QS is bisected, diagonal PR is bisected, which means each diagonal cuts the other one into two congruent parts. And then we have another little theorem here that seems like it's out of place. It says if three or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. And as I said, well, what does this have to do with parallelograms? The reason it's thrown in here is that you actually have to use parallelograms to prove this theorem, which we are not going to do right now, but that's the reason why we have this theorem thrown in here at this point, this lesson on properties of parallelograms. So it very well may be that you won't see that theorem again, or you won't have to use it in a proof at all. Okay, so there we go. We got those theorems, we got the definition of a parallelogram, we got some practice problems, and let me see. I guess I'm going to do a couple of them, and then I'm going to ask you to do the rest. I'll start with number 1 here. STUV is a parallelogram. Find TU and WT. Well, here's TU, and here's WT. And it says, justify your reasoning. Well, let's see, what do we know? First of all, we know that if we have a parallelogram, opposite sides are congruent by the theorem. So therefore, I know that TU is 12 because SV is 12, right? And they got to be congruent. Okay, how about WT? Well, the other theorem tells me that if a quadrilateral is a parallelogram, then its diagonals bisect each other. So since VW is 14, WT also has to be 14. Okay, how about one more? Let's see. I'll come down here to the bottom. I'll do this last one. Let me see what we got left. Okay, let me take it back. Let's go to the next page. Let's go to the next page. I'll work the 2 on this page with you, and then you can go back and finish the previous page for your extra practice. How about that? Sounds like a good plan. Okay, so we're on page 3 here, last page of this lesson. Find the lengths of the diagonals in the parallelogram. Okay, so what do we know? We know that the diagonals bisect each other. So we know that x equals y plus 2, right? Because I know that LP is congruent to PN and KP is congruent to PM. So let's see, we know that x equals y plus 2, and we know that 2x minus 8 equals y plus 10, right? What do we got there? System of equations, right? Okay, so what are the ways that we've learned to solve a system of equations? 2 equations, 2 unknowns. We can use combination or we can use substitution. This looks like a good one for substitution. I hope everybody was already thinking that. Why is it a good one for substitution? Because one of my equations is already solved for x. So what am I going to do? I'm going to take what x equals and I'm going to plug it in for x right there. So we're going to have 2 times y plus 2 equals y plus 10. So 2y plus 4 equals y plus 10. So 2y minus y is y, and 10 minus 4 is 6. So y equals 6. So let's go back. Let's go back now and plug that y equals 6 into this first equation because it's a little bit simpler. So x is going to be 6 plus 2, so x is 8, and so there we are. So there's the solution. If we needed to write a solution, we would write 8, 6, but they didn't ask us for a solution. They asked us to find the lengths of the diagonals. So let's see, if LP is x, then I know LN is twice that long, so LN has to be 12, right? And let's see, if y is 6, KP is 16, so 16 plus 16 is 32. KP is 32. Let me just double check in my head. Let's see, y is 6, 6 plus 2 is 8, 8 plus 8. Wait a minute. X, oh, I'm sorry, I got Ellen wrong. I got Ellen wrong. You knew that already. Many of you who aren't just blindly copying down. Look here at LP. LP is 8 because X is 8, which means PN has to be 8, so LN is 16. Sorry about that. And Y is 6, which means KP has to be 16, so that means the diagonal is twice that long, which is 32. So let's see, 2 times 8. 16 minus 8 is 8. Wait a minute. All right, so I've paused here and I've been looking at this problem for about 5 minutes. And I'm sure many of you have already seen where I made my mistake. I'll show you where it is. It's right here. You see where I plugged in y plus 2 for x? I forgot my minus 8 up here. Oh my goodness, I've been banging my head. I've been banging my head on the side here trying to figure out why isn't this working? Well, because I made an error. That's why it's always great to check our work. Let me try this again. So 2, I'm going to plug in y plus 2 here, minus 8, that's what I forgot last time, equals y plus 10. So 2y, let's see, plus 4 minus 8 is minus 4 equals y plus 10. So y actually equals 14 instead of 6 like I had before. Okay, so if y is 14, now I'm going to go back up here. I'm going to plug 14 in. So x is going to be 14 plus 2, which is 16. So if x is 16, that means Ln is 32. And if y is 14, then that means Pn is 16. Oh, sorry, I'm on the wrong one again. I'm trying to find the long one now. If y is 14, then that means this is 24. Let me plug in x here, 16, 32, 24. So yes, thank goodness it's working out right. So that means Kn is 48. Oh my goodness, how much trouble leaving out one number can cause. All right, I'm sorry for taking up extra time, but that's how things go, right? We're a team. We do this together. All right, we got a proof. Whew, we haven't had a proof in a long time, so I'm very excited about this. Here we go. Statements. And I know some of you are saying, oh, please don't write this down. Let us do it by ourselves. Feel free to stop right here and work this proof by yourself, and then you can just check it when you get finished. Okay, of course I'm going to write down the given first. It's given that ABCD is a parallelogram. That's what that symbology means. ABCD is a parallelogram. And what am I trying to prove? I'm trying to prove that AB is congruent to CD and that BC is congruent to DA. So I'm trying to prove the theorem that says if a quadrilateral is a parallelogram, then the opposite sides are congruent. So of course I can't use that theorem because I'm proving a theorem, but let's see what we know here. What do we know by the definition of parallelogram? We know that AB is parallel to CD. And I'm going to write this. I mean, this is the first thing I ever learned about a parallelogram, so I'm going to write it. And if that doesn't take me where I need to go, then I'll erase it and I'll write something else. BC is parallel to DA. And of course, the reason is the definition of parallelogram. That is the definition of parallelogram. A quadrilateral. Sorry about that. Phone interruption. Shouldn't have your phone when you're doing your homework. Okay, so we know that the opposite sides are parallel because of the definition of parallelogram. So let's see what I know. Now, I know that, let's see, that would mean angle 1 is congruent to angle 4, and also angle 2 would be congruent to angle 3. Somebody tell me in your head, why do I know this? Oh, because they're alternate interior angles. If I use that diagonal as a transversal, then I got alternate interior angles. Of course, that one's in the wrong place. That one's congruent to that one. 2's congruent to 3 because they're alternate interior angles. So alternate interior angles theorem. Okay, so how does that help us now? Now what I can do is I can say AC is congruent to CA. I have to be careful and look at my direction, and that is going to be the symmetric property, right? Symmetric property of congruence. And then I can say those two triangles are congruent, right? So triangle ABC is congruent to triangle. Ooh, I'm glad I color coded it so I know that A corresponds to C, CDA, triangle CDA. And how is it that those two triangles are congruent? Oh, by angle side angle. Two angles and the included side. Angle side angle. And so now that I have that, I know that AB is going to be congruent to CD, and BC is going to be congruent to AD. Why? Because they're corresponding parts of congruent triangles. So there I have it. AB is congruent to CD, and BC is congruent to DA because they're corresponding parts of congruent triangles. All right, so there's our proof. There are a few more problems. Remember, back here on the previous page, I want you to work those. I'll put the answers up, and then you can come check them. And then also for tonight, you're going to need to watch the next lesson, which is proving quadrilaterals are parallelograms. All right, here are your answers for these three problems. Please check them, put a star by them or a question mark or something if you need to ask me about them tomorrow. For the first one, you get 45 degrees. Second one, you get x equals 12. And for the last one, you get y equals 5 and x equals 18. The only confusing thing about this last one is I think you had to realize that this 50 degrees was for this entire angle here, and 7x plus 4 was for this entire angle here instead of just the little part that it looks like it's pointing at. So once you got that straight, you got it figured out, because you know if you got a parallelogram in consecutive angles are supplementary. All right, we'll see you next time. Tonight, also another lesson on proving quadrilaterals are parallelograms.